Okay, Algebra 2. No, you're not Algebra 2, you're Pre-Calc. I had my coffee and I'm ready to go for a second video. So, this is of the last review, which is a little bit harder than the other one, but a good practice for the test, because some of these problems I really like and you'll have variations of them on the test. So again, don't watch every single problem because it'll be kind of long to go through all of this. Just focus on the ones you think you most need help with. So these first two problems give us an ellipse, and they want us to find the center, the vertices, and your foci, equation of the foci. So center is going to be pretty obvious. In this first one, it's going to be 2, -1. Our vertices, those are at the endpoints of your major axis. So if my center is at 2, -1, and my major axis is 9 up and 9 down, that is going to put me up here. So they're going to have the same x coordinate. I'll be at 2 and then -1 plus 9, and 2, -1 minus 9 is going to be -10. Those will be my vertices. And then your foci fall right inside that. So to find the foci, we need to find that difference of c. So in a ellipse, it's a squared equals b squared plus c squared. So we have 81 minus 16 is going to equal 65. So c will equal the square root of 65. So the coordinate will be, we'll go out to 2, and then from a -1, we're going to go up and down the square root of 65. And that will be our solution for that one. On the second one, we're going to have to complete our square first. So you should be getting good at this. So x squared plus 6x plus 9, plus we have to factor out that 4, y squared minus 2y plus 1 equals -4 plus 9 plus 4. So in the end, it'll just equal 9. So we'll have x plus 3 squared plus y minus 1 squared equals 1, and then we have to divide everything by 9, which is going to be interesting. So we had a 4 sitting here. I'm going to leave it there. So this is over 9, and this is over 9. So that means I have a center of -3, +1, and then I'm going to have a vertices. So let's see. This really is 9/4 if I were to bring the 9 back down. So in this case, your major is going to be in the x direction. So we have here at -3, +1. I'm just kind of sketching it, and then we're going to go square root of 9 out, 3 back. So my vertices are going to be at 0, 1, right on the y-axis, and at -6, 1. And then my foci, once again, we have to solve for our c value. So we're going to have 9, let's see, 9 minus, this is 9/4, so 3/2 squared, 9 minus 9/4. This is like 36/4. So that is going to equal 27/4. So my c value will be the square root of that. So c is going to be 3 rad 3 over 2. It's a lovely number, isn't it? And so to actually write the coordinates, in this case, you're going to go back to your -3 and forward and back 3 rad 3 over 2, but everyone will be at the same y value of 1. Okay, that will be for number 1 and 2. Then, and I'm not doing this on the worksheet because there wasn't really a lot of room there to show your work. Number 3, you're writing the equation in standard form, given that the vertices were at 0, 2 and at 4, 2, and we have a minor axis, in other words, your B value of 2. Now that's the whole axis, so that means your minor radius, minor axis, that's 2b. So your minor radius is going to be a length of 1. So if I were going to graph that out, so we're here at 0, 2, I'm going to do everything by 2's, and 2, 4 out here at 4, 2, and that happened, those are my vertices. My minor is at 1 and 1, and so it would look like that. We'd be up here at 3 and down here at 1, and so we have that our, what are we trying to find? Oh, we just want the standard form. Okay, so my center is going to be at 2, 2, so x minus 2 squared plus y minus 2 squared equals 1. We know the minor radius was 1, so 1 squared will just be 1. And then to figure out, oh, well, we know that your A value is going to be 2 based on the vertices, so this will be then 2 squared. And that's it. So now we're on to number 4, where they give us that the center is at 3, 2. So our center, our HK, is 3, 2. And we have A equals 3C. So what that tells me is that my C over A is, so this is going to be a 1/3. And from there, we can, what else did they give us? Foci, 1, 2, and 5, 2. Okay, so let's give ourselves a little sketch so we can get our orientation down. Dun, 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 3, 2, so I want it out here. I'm going to again go by 2. So this is 3, 2. Here's my center. And my foci are at 1, 2. So here's a foci and 5, 2. 4, 5. So this is 5 and 1. So that is a distance. So that tells me that C is a distance of 2. So that means A is going to be 6. So C is 2, A is 6. All right, here we go. So we have x minus 3 squared plus y minus 2 squared equals 1. Our A value, in this case we're going in the x direction horizontally, so this will be 36, and we still need to figure out what our B value is, but we know that 36 minus 4 is 32, so that will be the B value. That's B squared, and that's really all I need if I'm going to do standard form. Okay, and then we are on to number 5. On number 5, vertices at 0 plus or minus 8, and E equals 1/2. So in this one, if I were to draw my graph, we're up here at 8, we're down here at -8, so what's friendly about that is my center is going to be at the origin, so that'll be friendly. We just have to figure out, and that was the vertices. So I know that A is going to equal 8, which means that my C value is going to be 4. So we can then, to find our B, A squared minus C squared is going to be 64 minus 16, which I believe is 48. That will equal B squared. So 64 will go here, and 48 will go here, and that is the answer for that one. I should probably circle these so you can find them. Doot. All right, I'm trying to save some space here. I know it's a little bit messy. Then we have number 6. So it says Stan is an avid runner, and he's going to create this elliptical track where you have 100 yards and 20 yards. All right, so we are 100 yards long and 20 yards, so that will put us at 50 and negative 50, and this will put me up at 10 and negative 10. And so how far apart will the cameras be if the cameras are at the foci? All right, so we know that A is going to be 50. We know that B is going to be 10. We know we're at 0, 0. So I know that 50 squared minus 10 squared is going to equal, I'm trying to see, 2400, which simplifies out to 20 rad 6. 4 times 6 times 100 when you take, so this is 4 times 6 times 100, so that's going to equal 2 times 10 rad 6. And so my foci are going to be twice that difference. So their width, or their distance between them, is going to be 2 times 20 rad 6, or 40 rad 6, what was it, yards everything was in? Yes, yards. Okay, and then on to number 7. So a lot of this is knowing what your eccentricity, E equals C over A, and those Pythagorean relationships. All right, on number 7 now we have a parabola, and we want to determine the focus and the directrix. So we have x minus 2 squared, I'll write down the equation, x minus 2 squared equals 2 times y plus 1. I always like to put my coefficient in front of the squared term. So if I was going to graph that, which I am, I have a center, or vertex rather, of 2, negative 1. So down here, so this is 2, here's negative 1. And we are oriented going, it's going to be a smile. And so we have the vertex. Do we have to actually label everything, or can I just graph it? Graph the following parabola, determine the focus and the directrix. All right, so I know that 1 over 4p is going to equal 1/2. So that means my p value is going to be, when I solve that, is going to be 2/4 or 1/2. So that tells me that my focus will be up 1/2 here. My directrix is going to be half below. And the distance is going to be a distance of 2 in this direction, 2 in this direction. So the graph will actually look something along those lines, where my focus is at 2, negative 1/2, and my directrix, which is the equation of a line, is going to be y equals negative 3/2. Okay? And number 8, let's see, I'm going to see if I can fit that on the same page and kind of do that one off to the side since it's the same instructions. For number 8, we're going to have to complete our square, so they gave us x squared plus 2x plus 6y plus 17 equals 0. So x squared plus 2x plus 1, that's going to equal negative 6y minus 17 plus 1 to both sides. So negative 6y minus 16. So here I have x plus 1 squared, and from this other one I can factor out a negative 6 that what I really want to do? Yes, I'm going to do that. That gives me, because you want your y term to not have a coefficient, so if I factor out a -6, this becomes 16 divided by 6, which reduces to 8/3, and you had to change the sign. And from there, I know, so I'm going to move this -6 over to here. And so my vertex will be at -1, -8/3. And my focus, because we're now going to have to set 1/4p, 1/4p equals your -1/6, so p will be 6/4, and okay, that's a lovely, p is going to equal 3/2. Hoi. All right, and my orientation here, so we've got y plus 8/3, and this one is going to be a frown, so that's why, well, it makes sense. Wait, so that means my p should be negative. These are negatives, so p is a -3/2. So where am I going to be? I'm going to have the same x value, but now I'm going to go down -8/3 minus 3/2. If you work that out, I believe it's -25/6. And my directrix will be on the other side. So that's going to be the equation y equals -7/6. Because you have -8/3, now you're going to add 3/2, and you're going to have to do some common denominator. So I'm not going to graph this one. You got the idea from doing number 7. Okay, so number 9, it asks us to come up with the equation given the center is at 4, -2, and our focus is at 4, 2. So let's go by 2's again. So if this is 4, this is going to be my focus. This is going to be my vertex. So our graph will have this orientation. So I know it will be y minus a -2 equals, well, let's fill that out in a second. I'm going to go back to x minus 4 squared. So this distance here between my vertex and my focus is a distance of 4. So 1/4p becomes 1/16. All right, that one wasn't too bad. Number 10, we are symmetric with respect to the line y equals 2. So that's like your axis of symmetry. And you are going to have directrix is the line x equals 4. Line y equals 4, x equals 4. X equals 4. And then p is going to be a -5. All right, so if we kind of sketch that one out, so this would be our axis of symmetry right here. So we know we're going to be on that line. And we know the vertex is, did they give us the vertex? Directrix is the line x equals 4. So this would be my directrix. And if p is a -5, that means I'm coming so this will also, so that same distance, if this is at 4, so my vertex will be here at -1, 2, and coming back another 5 would give me my focus. That would be at -6 there. So this is my vertex, that's my focus, using the fact that p is a -5. So I know my orientation is going to be in that direction, away from the directrix. And so let's go ahead and come up with our equation. So we are going to have the vertex again, -1, -2. So this is going to be x minus a -1 equals -1 over 4 times -5, or 4 times 5 in this case, 20. And then it'll be y minus 2 squared. I like that problem. All right. So the symmetry, when it said it was symmetric, that's like your axis of symmetry. So now let's move on to number 11. 11 is asking us, parabolic archway is 12 meters high at the vertex. So they gave you a diagram on the worksheet. It looks something like this. This point was 0, 12. They gave us a couple other points. This point was 410. They gave you -410. And they are asking how, at a height of 10 meters, the width of the archway is 8 meters. Okay, that makes sense because that was -410. And they want to know how wide is it at ground level. So basically you want to find your x-intercepts and that distance between them. So we need to come up with an equation. So your vertex is going to be 0, 12. We are upside down. So it's going to be y minus 0. Oh, sorry. Y minus the y value, which is 12, equals a. We'll solve for a in a second. X minus 0 squared. So I can plug in 410 to solve for a. So this will be 10 minus 12, which is a -2. That's going to equal a times 4 squared, which is 16. So we find out that a is a -1/8, 2 over 16. And so here's my equation. Y equals -1/8 x squared plus 12. And we want to let y equal 0 so that we can solve for x. So if this is 0, I'm going to bring that 12 back over. I guess I didn't need to move it over there. So we're going to have a -12 times a -8 equals x squared. And that is going to give me 96 equals x squared. So x is 8 rad 3 on both ends. So this is 8 rad 3. This would be -8 rad 3. So the distance would be twice that. So 16 rad 3 would be the distance from x-intercept to x-intercept. All right, on to number 12. 12 has several parts. Okay. Oh, I put these on here because you guys were struggling with completing the square for hyperbolas. So let's write this out. We have 9x squared minus 25y squared minus 36x plus 200y minus 589 equals 0. And I hope I'm writing that right. Okay, so let's start it off. We're going to reorganize 9x squared minus 36x minus 25y squared plus 200y equals 589. We start to factor out the 9, so this will be x squared minus 4x plus 4, so that means I'll be adding 36 over here. Factor out a -25, so this will be y squared minus 8y plus 16. So I'm subtracting 25 times 16. I don't know exactly what that is, but I'm going to write here minus 25 times 16. I do know that in the end that will equal 225 when you work it out. So now we have our 9x minus 2 squared minus 25 over y minus 4 squared. And we have to set everything equal to 1. So these get divided by 225. And your final answer is going to be x minus 2 squared over 25 minus y minus 4 squared over 9 equals 1. So that would be the result from completing the square. For part B, let's see what we got here. 2y squared minus 9x, 2y squared minus 9x minus 16y plus 14 equals 0. All right, so let's keep our squared terms on one side, and I'm going to move my 9x minus 14 to this side. So factor out a 2. So we have y squared minus 8y again plus 16 is going to equal 9x minus 14 plus 32, which is 9x plus 18, which is nice because you can factor out a 9. And so then we're ready to rumble here. We have y minus 4 squared, and that has a 2, and I'm going to bring the 9 over, equals x plus 2. All right, that was number 12. Whew, on to the back. We're almost going to make it, but I'm not going to be able to do it all on the same page, so I'm going to go one more page. All right, last two problems. Number 13, it wants us to write the equation of a circle with diameter at the points 4, 5, and -2, -3. So we want to find what is the length of that diameter. So I'm going to do the distance formula. So that gives me 4 minus a -2 squared plus 5 minus a -3 squared. That gives me 6 squared plus 8 squared. Well, it's going to be a 6, 8, 10 triangle because 36 plus 64 is 100. So I know that my radius will be a distance of 10. And now we can, my diameter is going to be 10, which means my radius will be 5. And I know that my center is going to be the midpoint between those. So you take the average, 4 minus 2 over 2, 5 minus 3 over 2. So 2 over 2 is 1, 2 over 2 again is 1. That was a nice center. So the equation will be x minus 1 squared plus y minus 1 squared equals r squared. And you're done. Then it asks for the area, circumference and area. Circumference is 2 pi r, so that will be 10 pi. And my area is pi r squared, which will be 25 pi. And that's it for that one. All right, last one, I believe. Number 14. So they give us this sort of, almost like one of your rotated hyperbolas. They're calling this a sculpture. And let's see what we have here. So we want to write an equation that models the curved side of the sculpture, which is basically a hyperbola. So let's go ahead and kind of just put down the graph of what they have here. Looks like our center is 0, 0, which is very nice. And I'm going to come in here, and I'm going to come in here. So these each seem to be at 1 and at -1. Up here we're at 2. It's kind of hard for me to read this. Does that say 213? I believe. And then we have symmetry everywhere. So 213, -213, that kind of stuff. All right. So here is our sculpture. So we know that HK is 0, 0. That's nice. We know that it's going to be in the horizontal direction. we have a particular xy value of 213, and so we know that our a is going to be 1, so I'm going to have, that was a really funky x squared. So x squared plus y squared equals 1. In the major axis is 1. All right, we need to figure out what b is. So in order to do that, we are going to plug in our xy coordinate. So I have that 2 squared, which is 4, plus 13 squared, which is 169, over b squared is going to equal 1. So solving for b squared, 1 minus 4, let's get rid of this first, is a negative 3. And so cross multiplying, so we have that b squared will equal 169. Oh, it's a hyperbola. Sorry, I was like, wait a minute, something's not right. Where's my little eraser tool? These should be minuses. So that makes it all better. This should be a minus, and this should be a minus. So we have a b squared equals a negative 169 divided by negative 3, which is just 169 thirds. And believe it or not, it doesn't reduce. Okay, so my final equation is going to be x squared over 1 minus y squared over 169 thirds, so I can put the 3 up here, over 169, equals 1. That's my equation, all right? Now, what else do they want to know? So each unit is 1 foot. Find the width of the, at a height of 5 feet. I hope I'm reading this right. Okay. So if I continued this sculpture on up to figure out what is the width when it is at a height of 5 feet, 5 feet would be, so that's a height of 13, So let's say this is where it is. So we're trying to find this width right here. All right, well that's nice. So we plug y is 5 into our equation. X squared over 1 minus 3 times 25 over 169 is going to equal 1. So x squared equals 1 plus 75 over 169. And we work that out. That 169 plus 75 is going to be 244 is what that would end up equaling. So x is going to equal the square root of 244 over square root of 169 is 13. And so to find the total would be 2x, which, sorry, but I'm not going to take the time to simplify that right now. That would be your answer. Okay, I hope this helped. I know this one went a little bit odd, but I'm sitting in a very strange place right now, trying to hide from my daughter so that I don't make a lot of noise doing this. All right, good night.